Okay, hello everyone. Welcome to the SingularityCE community call for December. So the last one for 2023, before everyone hopefully enjoys some holidays and a good new year. It's going to be a relatively short one today compared to some previous ones. Last month, if you weren't part of the call, we had a demo of the new build from Dockerfile functionality, where Omer, who was on the call then, showed how with 4.1 that will be out in the new year, you'll be able to build from a Docker file into an OCI SIF, which you can run in OCI mode. So if you didn't see that, I recommend taking a look on the YouTube channel link, which is highlighted here. It's on our messaging about this call, because it's worth saying that. So today, I'm going to start off with a demo of something which is less perhaps interesting on the face of it, but does allow us to do interesting things in future. So let me switch over to a terminal. And what I'm going to demonstrate here is a feature which has been added recently and will be out in the 4.1, where we can now ask Singularity to, when it's pulling an image in the new OCI mode, to keep layers. So up until this point, every SIF file, every container image you created with Singularity, whether you've built it or you've pulled it from somewhere, it's always flattened everything down into a single file system. So if you have a Docker container that you're pulling from Docker Hub, and it's made up of 20 layers because the image was built up in steps, then Singularity has always squashed it down into a single layer before creating the SIF file. Now that's good for performance reasons, because you only have one mount and it's convenient. It makes it easy to kind of ship around one layer because it naturally fits into a single file, or fits nicely into the native SIF images that we had before 4.0. Now we have this OCI mode in 4.0 and beyond. We can start exploring things which allow us to keep more information about the Docker containers which we might pull or build from. So what we have here then is the new flag keep layers. And if I ask Singularity to pull the Golang image from Docker Hub into an OCI mode, OCI SIF, and keep layers, what we'll find is it's going to go and fetch the individual layers. And then those were patched, so it was very quick, but it's now writing out this SIF image. We'll be able to look at it in a minute, and what we'll see is that rather than squashing everything down here, when it's saying it's writing this SIF image, it's not squashing down. What it's doing is instead putting each layer into the SIF file. So we'll have a number of OCI blob sections in our SIF image, and some of these are sort of an index to the SIF, or they're small things which are related to the image's configuration. There's a manifest and there's an image config in there. But then we also have all the layers, and these layers are now preserved individually. So things aren't squashed here. And when we run the image in OCI mode, I ask Singularity to execute it, and it's in that container, and it's showing me I've got the latest Go version. It's the right thing from Docker Hub. Behind the scenes, we haven't done a squash either. What we've done is make all of the layers available and then overlay them onto each other. So in this way, Singularity is working now much like other OCI runtimes, where layers are stored out on disk and then they're overlaid at runtime. The difference being that we're not storing them out on disk as folders with all the individual files in, we're storing them inside the SIF image. So each layer is a section in the SIF or a descriptor in the SIF, and then we're mounting that, and then we're overlaying there. So it doesn't look particularly interesting when I kind of show a demo like that. It just looks like it's doing the same old thing. We're pulling to a SIF image and we're able to run it, but it's just doing some more mounting behind the scenes. What's interesting though is where this will allow us to go from here. So our OCI SIF image with the layers kept is now something which holds all the information that was up in Docker Hub for that image. We haven't lost anything at this point. We know what the individual layers were, what the content of each layer was. So this will enable us to start bringing Singularity to have support for flows where you pull an image down from Docker Hub and you could push it back up to Docker Hub for consumption by another runtime without losing information. And this is important. We've heard from people who are heavily invested in OCI workflows where they use OCI images everywhere, but they might use Singularity just on HPC, and they want to make sure no information is lost, that layers are preserved and so on. And it also simplifies potentially some of the things we could do with the Dockerfile builds in related to caching and so on in future. So it's really a feature which is kind of a gateway to opening up new workflows which fit better in an OCI environment. And we're going to continue work on that through further 4.x minor versions. You'll see additional functionality there. For now, we can pull into a multi-layer OCI SIF. We can run the OCI SIF using all of those layers and assembling the root file system on the fly. And we can also push and pull the OCI SIF as is to the Sylabs Container Services Library or Singularity Enterprise, and to an OCI registry as an OCI SIF. So it can actually go up to an OCI registry with the layers intact, but those layers will be in Singularity's SquashFS format rather than the common tar format that other runtimes understand. So in future, we'll kind of expand that a bit so it fits in and it's even more compatible with these OCI workflows. Any questions on that little bit before I continue? Okay, let's have a look at the other stuff which has been going on recently since we last talked. So if I hop over to the changelog, we now have the keep layers flag, which I've just demonstrated. We saw the Dockerfile builds in the previous call. We've now also got this fourth bullet point here ready. So SCIF or SciF, as it's hyphenated on the web link here, is a specification for packaging multiple applications inside a single container, and then being able to choose which of the applications you run from that container when you are doing a workflow and you want one application at one step, another at another, but you don't want to kind of distribute tons of containers. So this is something which has been around for a little while and has probably mostly been used through Singularity, because Singularity's native mode has supported these containers which have SCIF multiple applications in them through special sections in a definition file, and then a flag. When you run a container, there's a --app flag, and you can use that to pick the application to run. What people don't necessarily always realize is that this standard isn't just for Singularity containers, it's also something you can use with Docker containers. So there's actually a tutorial, we follow this, which will show you how to build these Skiff containers using different workflows, whether you do it using this Skiff Python tool, if you're working in an OCI world, or whether you do it with a Singularity. So we've got Singularity there, and here's the Docker related instructions. What's happened recently working towards 4.1 is that the ability to use Docker or OCI Skiff containers is now fully supported in the OCI mode of Singularity. And you can use the app flag, and that will then correctly call into the OCI container that's set up according to the Skiff specification and run the correct app that you want, just as it would if you had a native Singularity container, which you'd built according to the instructions with the Skiff portions of a Singularity definition file. So we'll try and get a demo of that at some point later on, maybe look at Skiff in its entirety a bit more, see if we can perhaps invite someone to talk about it. But that is now present in the development branch and will be part of the 4.1 release soon. Any questions on this stuff? Okay, the last kind of bit from me is just to jump across to our development milestone on GitHub for 4.1 and see what's left to do. So you can see it's getting quite thin on the ground here now. There's not a whole lot in terms of features left to incorporate. Though I will say, given the nature of some of the stuff we've added, as we kind of complete these features, there's probably going to be a bunch of QA work, and we will find some bugs in some things before the actual release that we have to tackle. So the top one is just really for our peace of mind to add some more testing for a certain feature applying setcomp filters. And the bottom one here, this app armor profile for Ubuntu 23.10. This is a small thing for us, but it's potentially quite important for anyone who'll be installing Singularity on newer versions of Ubuntu going forward. And what this is that from Ubuntu 23.10, partway through the life cycle of this release, Canonical are going to turn on restrictions on unprivileged user namespace creation using AppArmor. So there's a link here, and if you follow it, it will give you a bunch of information about why unprivileged user namespace creation isn't always completely safe thing to offer on the system, what the risks are, and how you might mitigate those risks. And what Canonical are planning to do is basically deny applications access to create unprivileged user namespaces by default. And you'll have to specifically grant that ability to an application via an AppArmor profile and installing it. So we'll be looking at that and making sure that we ship and document a profile that allows Singularity to work in the different execution modes. This will affect anything except our setuid mode. Will rely on being able to create user namespaces in an unprivileged manner. So we'll have to get that all lined up, and we'll make sure it works going forward, so that when the long-term supported 2404 comes out next year, if they've chosen to switch this on for that, everything will be good. Any questions about that one? Because I know I've had a couple on chat and stuff in places. No, okay. The final things on our milestone then are the two issues here, which are related. So the top one here says use squash fuse in native mode when allow kernel squashfs equals no. And what this one is about is that when Singularity is run in setuid mode, it usually asks the Linux kernel to mount the container image, the squashfs file system from a container image, so that the files in the container are available and we can run the container. For various reasons, you might not want to use a kernel mount. You might prefer to use a user space mount with squash fuse. And this is actually what the OCI mode of Singularity always does. So we are going to have the ability to switch Singularity so that when you disallow kernel mounts, it will use squash fuse in setuid mode instead. The other one here for use fuse2fs, this is related to the same kind of thing, using a fuse mount, a user space mount instead of a kernel mount, but it affects really old container images before the days of SIF, when people built container images that were just really a single file holding a extfs file system. So ideally, we would support being able to mount those with squash fuse as well. There's a little bit of complexity here because there are different ways of approaching it, which have different trade-offs in terms of security. We could do the fuse mounts in different places, but depending on where we do the fuse mount, we have different requirements. We might need a system administrator to allow some special option for fuse mounts, or we might require that the fuse mount is done using fuse 3 instead of fuse 2, and that's an issue because this fuse2fs doesn't support fuse 3. So we're working on this at the moment, and we've kind of explored various routes. And we're now at the point of looking at it in depth to make a decision what's the best route given the use cases we know people have in SingularityCE and Singularity Pro, and we'll start the actual implementation of that very soon after. So that's where we are on 4.1. So really fairly short update today. I'll open the floor if there are any topics you'd like to discuss or any questions at all. Be glad to go through them.
DT, any thoughts on why Canonical is going down the road of restricting unprivileged user namespaces? I know you said that'll be necessary, but why have they made that change in the first place?
So if you follow through to the linked article, sorry, I've lost my link here. Let me find it. Highlight what they have, right? So they've got a section here, right, about what are the security risks, and basically it boils down to user namespaces being a feature which kind of exposes a lot of the kernel that wasn't really previously accessible by normal users to normal users, and input from those normal users when system calls are made and so on. And what you have really is this general idea that, you know, the more that is exposed, the more likely you are to have some kind of security issue, find some kind of bug where there's a bit in the kernel, a bit of code which isn't properly anticipating how it could be used by a normal user rather than root, now that user namespaces are available. And then they kind of allude to this when they start talking about where most exploits kind of fit in here, right? So they're citing a report from Google where using unprivileged username spaces as part of the chain of actions or features you have to to kind of bring into play to make an exploit work. And that's now being seen in 44% of the exploits that Google has reported in this, right? So this is the reason why they're kind of considering locking this down. User namespaces give access to normal users to huge amounts of the kernel that was previously only accessible by root. And therefore that any kind of latent bugs in there or things can be exploited. So you don't want to have anyone able to do this unless they need to do it. And we can kind of lock it down to specific programs so that we kind of trust that a container runtime, it's going to need a user namespace, going to need to create that, but it's not going to do things which are then really hammering the certain syscalls or whatever and trying to find an exploit, perhaps. That's the kind of aim here, I think. Does that make sense?
Yeah, that's great. Thank you.
So Dave, do you think that the mitigation for Singularity is just going to disable this, or it will be able to make an app armor that still blocks some things but still makes Singularity work?
I mean, that's what we've got to look into, right? So one of the points here is that they have added a new flag default allow, right? So you can just allow a program to do everything, including using user namespaces, but really that's ideally not what you should do. You should try and write a profile which is more specific. So we will be trying to do that. I mean, a container runtime definitely needs to do quite a lot of stuff. It has to do a lot of mounts. We have to do it to root, a bunch of things which are going to be result in an app armor profile which is quite permissive. But yeah, we should definitely try and approach it and not just allow everything if we can do that at all possible.
Yeah, because in my evaluation of all those exploits, that almost all of them are with network namespaces. So if you were to be able to block the use of network namespaces from unprivileged user namespaces, that would go a long way. I think that would there's not an option that's given on other kernels. You either can turn network namespaces on and off completely, or user namespaces on and off completely. You can't say no network namespaces from user namespaces. I think that's where most of those exploits come through, in the network region.
I mean, I'd agree that a lot come through the network region, but I wouldn't say most. I think this is a discussion we've had before, actually, how on certain operating systems it's almost been like that, but on others it hasn't. We have quite a complicated mix of kernels and backports and all kinds of stuff across the long-term distributions that people tend to use in HPC. And honestly, there are a lot of things which aren't network namespace related, which have come up, but are potentially only on distribution A for vulnerability 1 and distribution B for vulnerability 2. I think,
of course, they all use the same kernel, but yeah, the ones that I've followed, at least for Red Hat, yeah, it seems to be almost all network.
It's
and that Ubuntu article linked, I'm noticing like there is actually a file system one that's quoted there, 2022-0185. So yeah, I mean, I guess it. Sorry.
There are two file system ones I can remember mentioning to people, in fact, which aren't network namespace. But regardless of it, obviously what you want to do is try and approach this in a way where if we can disallow things which we absolutely don't need, we will do that. I have to put my hands up and say I don't have a vast amount of experience with AppArmor, so I have to do a bunch of reading, and we have to look at what's possible to filter here without causing issues. But that's some work we're going to do. Anything else anyone wants to bring up? Okay, I guess we'll call it a day for now. I hope everyone has a nice end to 2023 and a good start to 2024, and we look forward to seeing you in January, when we'll be a bit closer to getting out 4.1, and we look forward to that, and then looking onto the roadmap for 4.2. So like I mentioned at the start, if you haven't seen the Docker farm build yet, go and take a look at that on the YouTube channel for the previous recordings of these meetings. There we go, the November 2nd one. Otherwise, thanks for joining us, and hope to see you next year.
Cheers, Aaron.